demonstration. Please follow the demonstration. Later I will give all the relevant materials, including the recorded video also, and then you can try that in your system. Okay. And if you have any queries, you stop me then and there. I'll explain slowly and clearly each and every step. Once you invoke the tool, you will be landing up to a page like this. Okay. So this is Intel Quartus Prime Lite Edition. So there are various windows are there. You can able to see on the left hand side the project navigator. So in this project navigator, you will be able to see the hierarchy. So what do you mean by hierarchy? In this case, for example, I'm designing a counter. When you're designing a counter may be the top level block. And within the counter, you should have realized this using T flip-flops maybe. Now this T flip-flops again, realize using D flip-flop and a NOT gate, right? So this is a level of hierarchy. Okay, counter T flip-flop followed by T flip-flop. So all this hierarchy on your design will be able to see. And there is a drop down here. So what are all the files associated with your project? You can able to see all the files, okay, with the file extensions. And what are all the IPs that you used? And is there any revisions that you have? All these information you can able to click this drop down and then you can able to see that. Okay. So this is the project navigator. Then you can able to see the task window. So in this task window, the design flow, whatever I explained, right? After doing the function simulation, if you are compiling the design, it will do analysis and synthesis, and then it will do the place and route, and it will generate the programming file. If you want a specific timing analysis to be done, then you have to give the constraints and it will do the timing analysis. And after that, it will write the post-fit netlist. So these are all the steps will be carried out when you're compiling your design. I can restrict the compilation based on either I want to do a full design or I want to do only RTL or I want to do only at the gate level. You can choose it based on your design stage. So by generally, either you use a full design or the full compilation. Okay. So this is on the task window. So you can able to see when you're running the project, you can able to see the progress in this window. Then comes the console window. So in this console window, you can able to write the script. So all these compilation activity, the design flow various stages, which I was explaining to you, I can run through the scripts also. In this semester, I hope you are learning script. Since you are a beginner, we are not going to use a script, but for certain applications like making the pin assignments and all, we'll use this tickle, okay, the console window, where we'll be typing the script. So that will be readable by the Quartus Prime, okay. And here you can find the message window in the bottom, where you can see the red color cross, there is error, and then warning, all this information while you're compiling your design, it will be listed here. Okay. So the message window. Now this is the workspace you can able to see. Suppose you're doing a design with schematic or a block diagram design entry, your schematic editor will be opened here. Suppose you are doing using Gorilla Hostel, then your text editor will be opened here. Okay. And on the right hand side, you can see the IP catalog, which will be installed while you're installing the Intel Quartus Prime. So you can directly use these IPs for certain application where you require these IPs to be used. Okay. So later in this course, we'll be taking certain applications from this IP library, and then we can make our design. Okay. And apart from these windows, you can able to see various tabs starting from file. You can able to see how to create a new file or to start a project. Okay, so we'll use these tabs. We'll try to understand these tabs over a period of time. Okay, once you start a design and then if you can completing a couple of projects, then you will be able to use this effectively. And you can see the iterative windows. So some of the windows which was shown here, suppose if it is not available, you can able to get those window from here. So we iterative windows, and in this case project navigator, it has gone now, right? So again iterative windows and project navigator, you get the window. So all these windows, whichever windows that you want to see, you can able to take from view iterative windows. And under the project, suppose you want to archive the project or you want to create a revisions on your project, at that time we'll use this. Today I will tell you how to archive a project and how to restore from the archived project. Okay. And assignments. Now, as I told, we are going to implement in Cyclone 5. Then we need to make the assignments to it. Right? At that time, we'll use this assignment tab, and we will be assigning the external IOs to the device IO in order to realize the function. Then comes to the processor. So all the compilation activity will happen in this processing window, especially you start compilation. And then at each stage you can able to see the compilation reports also. Okay. And then tools. There are a lot of sign-off tools are available. Over the period of time you try to use as such, and then you can understand it. Okay. And if you want to detach each window, you can able to do, and then you can get this detail. And finally, under the help, you can get the tutorials, all the information related to the Quartus file. Okay, you can see the PDF tutorials are available. So this is just a basic overview which I have given to you. Any question? Okay. So if you install the Cyclone 5, here you can be able to see the device family, Cyclone 5. So I've installed Cyclone 10 for all these things. Other devices for you is not required right now. Cyclone 5 is fine. Now, can we start with the project now? So to start the project, first we need to do the paperwork. So what is our design and how we are going to do it. So the very first step is you are going to do the paperwork. Well, let us take a very simple example, half a day. So last week I told you to review that, right? Maybe you can take that, you can go through that. So you might draw the logic circuit, you might draw the truth table, and you might draw the Boolean equation form, right? Now with this understanding, now how to start a project and how to make the design and how to verify the design and how to implement that design in the target FPGA. So this is the flow that we are going to do now. Okay. To begin with, go to File and then New Project Wizard. So first you will be getting a pop-up window. You just try to read this pop-up window where it tells that in this wizard we will be creating a new project and a preliminary project setting with respect to the project. So you'll be creating the project name and then the directory, the name of the top level design entity, and then project files and any libraries specific to the project. And very importantly, you are going to choose the target device family. And finally, is there any additional EDA tools that you're going to use it? Okay. So just click next. Now, the very first step here, you are going to do the directory name. By default, it will choose a directory C Intel FPGA Lite 18.1. This is the installation path. So I always recommend you to create a new directory in this path. Okay. So now, for example, I'm giving lab one. Okay. Don't try to give a space. Okay, lab space one or some name like that. So without space, in a single word, you try to create a directory, and you have to give the name for this project. So you can give whatever name you want. Again, provided try to give a sensible name respective to the project. So in this case, half adder. Again, don't give the name like half space added. Even you are trying to give that space, it won't allow you to do it. So there should not be any spaces allowed. Okay, on the project name. And as you can able to see, the name of the project when I'm typing, it has automatically taken here. So what is this? It is a top level design name. Each design will be having a design entity name. We also call it as a module. So this is again a case sensitive, which is similar to the project name. So in this case, the counter is a top level module. Okay, so here I should give as a count. In this case, I'm giving half ad. Okay, clear? Click next. Now it is telling that there is no such directory. You want to create it? Yes. Now on this path, it will create a directory called lab1 and then it will create a project name called half-end. Then it is asking the project type. Select the type of the project which you want to create it. Whether you want to create an empty project, that is creating a new project by specifying your project file library and then target device family and all, or you want to choose a project template which is available in the design store. Right now, we are not going to choose the project template. We are not going to do anything with the help of design store, which is available in Intel FPGA cloud. So right now, we are not going to use any of this. We'll click on empty project and then click next. Then you land up in the next pop-up window where in this section you want to add any file. Select the design file you want to add into this project. For example, already you created a design file, let us say a Verilog file or a block diagram file or an IP file, which is already available. Then you can able to browse it and then you can add it into your design. Right now, I don't have any such design, so I can skip this. And also, you can specify any non-default library that is user-specific library specific to the design that you want to do it. Or if I'm accessing any certain IP from the vendor, then those IP libraries, user library has to be added. At the time, we'll be using this user library. Right now, we are not using any such kind of, okay? So leave this field as such and then click next. So this is a very important settings. Here we call that as a family, device and board setting. Since we know what is the board we have in our hand, now we can able to choose the tab board. So there are two tabs. By default, it will be device tab and there is another tab called board. Now we can able to see the Cyclone, D1 SoC board. So here we have Cyclone 5 family and this is a device name. So you can make a note of this device name also. Okay. Later I will share this information, the complete information of this also. Okay. And what about the logic elements? We call this as adaptive logic module in this case. And how many number of IOs are there, GPIOs. Okay. So this information down the line we will try to understand. And how many number of memory bits, DSP blocks, so on and so forth. Okay. And it has on-chip cores are also available. So in this case, it is ARM processor. Okay, so you can choose. Suppose if you are not very sure about the board what you have, the device number, then you can go to the device and you can choose the family, choose the package type, FPGA. FPGA stands for Fine Ball Grid Array Package, and if you know the pin count and if you know the speed, then from this you can able to drop down, you can able to choose the target device family. Okay, so either way you can do it. Okay. So now right now I'm just going to choose that since it's an easiest way that I can able to choose it. So I chosen D1 SoC board, that is the target board that I'm going to use. Click next. So in the design flow, I was telling that even you can use some of the third-party tools, right? For example, you want to do function simulation using Model Sim, then you should have installed that Model Sim in your desktop or the laptop, and you need to provide the link of the path of the executable. Thereby, you can use that. Okay, so in this case, if you are trying to use any other EDA tool, you can use that from the drop down. Okay, and similarly for the design entry procedure, board level in terms of timing, all those things. Right now, I'm not going to use any other vendor EDA tool. I'm going to use only Intel Quartus Prime for my design. So I chosen none, and then I'll click next. Now you can able to see that whatever I've done so far, you can able to see this. So don't skip any of the window. Carefully go through it. So if any corrections to be done on your project wizard, you can always go back and then you can check it. So you can see the project directory which I've created, the name of the project, top level design entity, family name, device, board detail, and for this target board, what is the core voltage and temperature. I have not used any other EDA tools for this design. Okay. So once I make all these settings and then click finish. Now, once you click finish, you'll be able to see that the Cyclone 5 device family, the target board, whatever you have chosen, and the project name, right? So now we can able to see there any files, still no files because I have not added any files to my design. Okay, so I need to add the design file for this particular project. So here I'm going to use a design entry method. The first design entry which we are going to take schematic based. Okay, so for creating the design, again go to file, new, then you can able to see what are the design files supported in Intel Quartus Prime. Active HDL, block diagram or schematic, electronic design interchange format. So as I told, if you're using third-party EDA tool, you can get this EDA file and then you can import the EDA file directly to Quartus Prime and then you can do it. This is a system file for system level design, state machine file, system verilog, tickle verilog, and VHD. Okay. So in this course, we'll be learning how to do with block diagram, schematic, and Verilog HDL. Okay. So now I'm choosing the block diagram or schematic file and then click OK. So now you are getting the schematic editor where we are going to make our design entry here. So you have in your notebook, you are going to use one XOR gate and one AND gate. Okay. So in order to have a better visibility, I recommend you to detach this window by right clicking on this tab. You can detach this window and you can maximize to the full screen on your desktop or laptop. Okay. Once you're done, you can able to see various tabs are here. So here you can able to see a tab with a gate and gate symbol. So by placing the cursor, you will get to know what is these tools and all. So this is a symbol tool. So by clicking this symbol tool, we'll be getting the pop-up window. On the left-hand side of the pop-up window, you will be finding the libraries. So by elaborating this tab, you can able to see that primitives, others, and mega functions. And again, if you elaborate primitives, you will be getting buffer, logic, pin, storage, and all. And again, if you could elaborate the logic, now all the logic gates are available, the primitives are available. So first, I'm going to choose a hexa gate that is required to make my half array, right? The sum logic. So just click on this particular XOR. You will be getting the image, symbol image of it, and then click OK. Now you can able to see the image of it. So wherever you want to place it, you can do a left click on the mouse. And in order to deselect it, you can use escape. Okay. Again, I'm repeating. To place it, you can do the left click mouse, and to disable this selection, you can use escape on your keyboard. You can find the escape button, right? Now, in the same way, click on the symbol tool, and now I'm going to choose the Android. Okay, and I use escape to deselect it. My voice is audible?
Yes, sir.
Okay.
Yes, sir.
Because now I recommend you to click on this zoom option and zoom in before going for the wire connections. Okay, because we always tend to make mistakes while you are doing the connection. So I recommend you to use the zoom tools here, and then you can zoom it and then you can do it. Now we need to make the IOs. Right? Again, you can able to see pin tools. You can find input, output, and bidirectional. So I'm choosing output. We will be getting an output tool here, and then we can place it. Similarly, we can place it. Okay, and deselect by clicking the escape button. Okay, and similarly, in the input. You can make selection using control, and then you can adjust the positions on the grid. And now I'm going to use, there is a tool called orthogonal node tool, and I will be connecting this. And so you can rename the pins also. Whenever you want to deselect the node tool, again you can use escape, or you can go back and you can use the selection tool. Okay. So you can use selection tool, hand tools are available here. Okay. Or just double click on the pin. You can rename it, whatever the name that you want. So, but you have to remember this. This should be case sensitive again.
Sir,
Yeah.
if we need 2 or 3 or more JOR gates, so we can copy paste from here itself.
Yes. 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 Any number of
Okay.
gates, any number of times you can copy.
Okay, sir.
So while you are choosing actually you plan that's what you have it in your paper, how many number of gates is required. So those many number of times you can place it and then you can. So now what we need to do, we can zoom out and you can see that good, fine. Whether my connections is correct or not, I need to check, right? So before that, I'll just go to file and save this. Okay. So by default, it will take you to the directory where it has created the project for you, right? And the default name that it will be saved is .bdf. So the block diagram design file or the schematic file. Okay. So just save this. Then I can verify whether my connections are perfect. So you can click on processing here in the editor itself, and you will be getting analyze current file. Okay, Suppose if you're not detached with the window, you won't get this tab here. You will be getting the tab here in the processing window. Okay. Right now I detached the window. That's why I'm getting this tab here. Okay. So click on analyze current file. Now come back to the Quartus Prime window. You can able to see it is running by seeing on the right hand side bottom. You can able to see the time when it's running and the percentage, right? So it is analyzing the schematic file what we have created. Okay. So analyzing the current file was successful. 0 errors and 1 warnings. Generally, you can ignore warnings. If you want to know, you can click on the warning and you can see. Okay. So it is telling the number of processor has not been specified. So this is basically, in my laptop, what is the core number of processor which I can able to mention in the Quartus Prime. Thereby, I can improve the performance. So in the forthcoming lab class, I'll tell all these settings how to make. Okay, to run in a better way. Coming to the design is done. I've saved it. I've analyzed the current file. Right. The very next step, I need to check its functionality. Okay. So before checking the functionality, I will compile this entire design. So whatever I created. Now you can able to see whether this file has been created. Under the hierarchy, you can able to see the files. So this is now been added, right? So now before going for the function simulation, I'm compiling the entire design. So by clicking start compilation under processing. Now you can able to see the task window become active. Now under the compile design, I have given full compilation. Now first step, it do analysis and synthesis. So in analysis, it will check still is there any logic connection errors are there, or with respect to the cell whatever I used any errors are there. In synthesis, it will convert your block, whatever the schematic that you made, back to the device specific, that is Cyclone 5 target technology, and it will choose primitives. Okay. And the next step, it will choose the necessary logic element in the Cyclone 5 FPGA. It will place these logic functions into the logic element, and it will connect them together roughly and to realize the function, and finally the assembler will generate the programming file. The another job of fitter also is it will tell that whether your design able to fit into this target device or not. For example, this Cyclone 5 FPGA has 85K logic element. Suppose your design requires 100K or more than 100K, then the fitter will tell that I can't fit it to the target device. That means you have to change this to some other target FPGA which meets your requirement. Okay, so that is the job of fitter basically. Right now, I have not given any specific I/O information, so it randomly chosen certain logic element and it has placed and routed, which I cannot target to any target FPGA, even in this case I got 5 also. So then what I need to do, I need to do the function check. After doing the function check, I need to make the I/O assignment. After making the I/O assignment only, then it becomes to the target device specific, and then I can able to implement into the target FPGA. Okay. Now I made the complete compilation completed. There is no error. There are few warnings which you can ignore right now. Later we can deal about these warnings. Once it's done, now we are going to do the simulation. Right now we are going to use the simulator which is available as a part of Quartus Prime. Thereby we will be using this installed model sim from the Quartus Prime. So how to use it? Go to File and click New, and you will be getting a section called Verification and Debugging Files, and there is something called University Program VWF. So this university program VWF stands for Vector Waveform File. Okay. So this vector waveform file I'll be choosing it. Okay. Now you'll be getting a pop-up window like this. So this is a waveform editor. Now I can add my system I/O signals. Here in FPGA, these signals also called as a nodes. So the Intel Quarterspine will treat them as a node. For example, in our design, A is one node, B is one node, S is another node, C is another node. Okay. Now I need to import all the nodes here. So just double click on that. By double click, you will be getting the pop-up window where you can insert node or bus. So how I can get the nodes? By using the node finder. Click on this node finder, then you will be getting an option, filter option. You want to filter by pins. So in this case, I'm going to choose pins all and then just give it pins all and then list it. Okay. So if you list it, you will be getting all the pins associated with your design. So in this case, I will be having all the global pins as well as the local pins also. In this case, in our case, we have only the global pins. A, B are my input global ports, and sum and carry are the output. Now these are all terminology as far as FPGA is concerned. It is nodes. Okay, so we need all these nodes to verify the functionality. So you can choose it using control option, select all the nodes, and then copy to the selected nodes by clicking it and just give it. And then OK. Now you get all the nodes here. What about next class time?
Sir, no next class, sir. This is last class, sir.
Okay. Can I extend another 10 minutes?
Yes, sir. Yes, sir. Please, sir.
Yes, sir. Yes, sir.
Yes,
Yes, sir.
If it is boring, tell me, I'll stop.
No, sir. No, sir. Go ahead, sir.
Fine. So now I have inputs A and B here and sum and carry. So there are different ways that I can able to provide the stimulus. That means I need to provide the test vectors. I need to verify this, right? So before that, I will just set the total simulation runtime and grid size and all. So how I can do it? Go to edit, and there is an option called set end time. So what is the maximum time that I want to run this simulation? So you can choose either in microsecond or nanosecond time minute. I'm using nanosecond and I'm using, let us say 100. Okay. So now you can see the width 100 nanosecond. And I can choose grids at every 10 nanoseconds. You can go to edit, grid size, and then 10 nanoseconds. And then give OK. So every 10 nanoseconds. Now you need to assign the test vectors as per the truth table, whatever you have, right? So one way that you can use it, you can click on the left mouse, left click, and then you can drag, and then you can select the signal, and then you can click on high or low, right? So you can do it that way. Like that, you can choose this, okay? And then make your high impedance so and so. So different logic levels that you want to make it. Okay, this is a one way that we can do it. There is another way that we can able to make it. So now I'll explain you how to do that. So now I'll be choosing this variable A, and here you can able to see the count value. Right. So now at every 10 nanosecond, the value start value will be 0. At every 10, it will become 1. Again, it will go 0. It will go 1 like kind of a clock. Right. Now you can able to see this. Right? Now select B, again choose count, and now I'm making this to 20 nanoseconds. Now you can see here. Now there is a cursor here, right? And you can able to see now A0, B0, now A1, B0, now A0, B1, and A1, B1. All the possible combinations now I could able to cover. Like that, if it is of a 3-bit or 4-bit in the same way, you can change this value and then you can able to verify all the possible combinations. Okay. Don't try to force a value for SNC. This is what we need to test it, right? So now we are given the stimulus, the test cases to test our half-adder design. Once you make this, then you can go to File and then Save. So you can save with the name half-adder. And this will be saved as .vwf. VWF stands for vector waveform file. Okay. So now I've saved this. Then before going for the simulation, there is an option called simulation here, and you can find simulation settings. So you can see whether you want to like kind of function simulation to setting, timing simulation setting, and then very low. Okay. So let this be default now. Now the simulator settings, you have to check before going for the simulation whether you are given the path. So come back to Quartus Prime, go to the tools menu, okay, go to the tools menu, and there is a options tab, okay. Click on this options tab, you will be getting a pop-up window, okay. Then you can find EDA tool options, okay. Again, I'm repeating, under the tools, options, and EDA tool options. Now you can able to see this model sum at okay. This is what we are going to use it. Now you need to give this path. So where I can get this path, all of you might install it. Most of the cases will be in the same path only. So you have to provide a browser and provide the path to C 18.1. There is a directory called model sim underscore AAC and Win32 LOEM. So under this directory only the executable are available. Okay. So why this path is required, we'll understand now. Coming to the vector waveform file. Now I'm going to do the simulation. So now I'm going to do the functional simulation. Okay. So you can do model sim test bench and script, and then you can go for, or you can directly do the run function simulation, which in turn will generate the test bench. So I'm clicking run function simulation now. Now you can see it is generating the test bench based on the pattern whatever I have given here. Okay. See, since I ran earlier example, if you could remember the vector waveform file, whatever we have saved is half-adder.vw. Okay. So the simulator has taken the earlier vector waveform file, which is not matching with the one whatever I'm trying to say. So you can click on restore defaults and then you can save it. So how to do it? Again, I'm repeating. Under the simulator setting, you can click on restore default and then you can save. Then you can go to simulation. So now you'll be getting another waveform editor, which is your output. As you can able to see, you can drag the cursor and 0 0 sum 0 carry 0, 1 0 sum 1 carry 0, 0 1 sum 1 carry 0, 1 1 sum 0 carry 1. So you verified your functionality. So we have done the first part, right? Any questions so far?
Sir, how can we add delays, sir? Delays for the gates.
Right now, we are not going to add any delay, and later I will explain the concepts of delay. Okay. And moreover,
Thank
delay modeling, all these things will be only for the simulation.